Imagine a roofing material that has endured for over 8,000 years, offering both insulation and weatherproofing naturally, leaving almost no carbon footprint and capable of lasting as long as 60 years. Yet, in the United States today, fewer than 20 homes feature this type of roof. This is the thatched roof, the most ancient roofing method known to humankind. We will explore the physics behind its effectiveness, the unique structure it forms, and the reasons it disappeared from U.S. building codes. Long before slate was quarried or terracotta molded, humans relied on dried plant materials to shield their homes from rain and wind. The earliest evidence in Britain points to the Starcar structure in North Yorkshire, dating back to approximately 8,500 BC. By the Bronze Age, circular thatched houses dotted the English countryside, with some on Dartmoor reaching 56 feet across. One Iron Age dwelling on the Minute Hills, measuring 50 feet in diameter, would have required around 8 tons of straw or 3,000 bundles of water reed to cover its roof. By the early 19th century, nearly 100,000 buildings in England boasted thatched coverings. Across the globe, independent societies reached similar solutions using local hollow-stemmed plants. In Hawaii, shelters were thatched with tea leaves, laya from the pandanus palm, and pili grass. In Bali, the multi-tiered Mu towers of the Besaki temple were roofed with the black fibers of the sugar palm. Fijians combined fan palm leaves with layered reed walls to build their roofs, while in Africa, Kikuyu tribal homes were covered with highland grasses. Meanwhile, in the Americas, the Maya, Inca, and Aztec all relied on thatch, and even today, thatched construction remains common in the Yucatan Peninsula. Though materials varied by region, the underlying principles were universal. 2 key physical mechanisms make thatching so effective. And the first is fluid dynamics. Thatched plants, whether water reed, long straw, palm leaf, or grass, are installed with their butt ends outward on a steep pitch of at least 45 degrees. At this angle, rainwater flows along each stem, cascading from tip to tip until it leaves the eaves. Only the outer inch or two of a 12 to 15-inch thick roof face the weather at any moment. The interior remains dry, even through prolonged storms. When compressed to roughly 8 pounds per cubic foot, water reed prevents significant moisture penetration, and the outer layer quickly dries through natural air circulation once the rain ceases. The second principle is thermal insulation achieved by trapped air. Each hollow stem holds a column of still air, with additional pockets between bundled stems. Static air is a powerful insulator, and a 12-inch layer of thatch forms a continuous insulating blanket across the roof. Data confirms this. A 12-inch water reed roof reaches a U value near 0.29. Measured in watts per square meter Kelvin. By contrast, clay tiles and concrete slates have thermal conductivity ranging from 1.0 to 1.5 watts, offering almost no insulation. Consequently, a thatched roof reduces heat loss by roughly 93% compared to an uninsulated tile roof, without any extra insulation required. Not all thatching materials perform identically. Different plants bring distinct benefits. Water reed, for instance, contains the highest silica content among domestic plants. As it grows, it absorbs silica from wetland soil and deposits it as amorphous opal phytoliths in the stem epidermis, forming a naturally glassy coating around each fiber. This silica layer is hydrophobic, structurally rigid, resistant to microbial decay, and hostile to organisms that would otherwise decompose organic materials. Thanks to these properties, water reed outlasts long straw by several decades under identical conditions. The case for thatched roofs has strengthened over thousands of years, particularly when it comes to thermal performance. Studies in tropical regions reveal that thatched roofs maintain temperatures 27 to 36 degrees Fahrenheit cooler than metal roofing under identical conditions, and run nearly 2 degrees cooler than terracotta tiles. The environmental advantages are equally striking. Clay tiles emit around 5.5 pounds of carbon dioxide per square foot, while concrete tiles produce roughly 2 pounds per square foot. In contrast, natural thatch embodies almost zero carbon, being hand-harvested with minimal processing. The carbon absorbed during the plant's growth remains locked in the roof throughout its lifespan, and at the end of its use, the material is fully compostable. Compare this to the U.S. asphalt shingle industry, which generates over 12 million tons of landfill waste every year, and the ecological benefit of thatched roofs becomes undeniable. Lifespan, however, remains a relative consideration. Some alternatives last between 15 and 40 years. Clay tiles, for instance, endure from 50 to 100 years, which makes thatch seem less impressive. Yet when measured against asphalt shingles, which cover approximately 75% of residential roofs in the United States and typically last 20 to 30 years, thatch proves fairly competitive. Beyond performance, the aesthetic appeal of these roofs is extraordinary. In 1999, architect Bobby McAlpine's amphitheater for the Alabama Shakespeare Festival demonstrated thatch's ability to meet both structural and visual demands in a high-profile American project. This example, though, is just the tip of the iceberg when integrating ancient techniques with modern design. Internationally, several contemporary buildings showcase the synergy of traditional thatch and modern architecture. The Thread Cultural Center in Sagel, the Lanzerhof Sylt Health Resort in Germany, and the House of the Five Senses in the Netherlands stand as remarkable examples of what can be achieved. Particularly notable is the Enterprise Center at the University of East Anglia, completed in 2015. It was the first large-scale commercial building in the United Kingdom to secure both Passive House certification and a BREEAM outstanding rating, the highest performance standards globally. This structure is enveloped in 300 prefabricated thatch cassette panels. And in 2021, COP26 recognized it as one of the 17 most exemplary sustainable buildings worldwide. Across the globe, the tradition of thatching is experiencing a revival. In Japan, about 100,000 properties still use thatch, maintained by roughly 300 skilled thatchers. UNESCO recognized the Japanese Kyabuki thatching techniques as intangible cultural heritage in 2020. In the Netherlands, 4,000 to 5,000 new thatched roofs are installed each year. Yet in the United States, thatched homes remain almost non-existent, with only around 20 known residential properties. The primary obstacle has been fire risk. In 1630, Boston banned thatched roofs after fires swept through tightly packed frontier settlements with primitive wooden chimneys, a restriction mirrored in other parts of the country. Over subsequent centuries, fire fears persisted, fueled by incidents like the Great Boston Fire in 1872, largely blamed on dense clusters of buildings with wooden mansard roofs. The resulting International Building Code, now adopted across all 50 states, mandates that all roofing materials undergo fire classification testing. Materials such as brick, masonry concrete, metal, clay tile, and slate achieve Class A automatically because they are inherently fire resistant. Untreated natural thatch, however, cannot reach even Class C under these testing standards. While the code does not explicitly prohibit thatch, its requirement effectively bars untreated organic roofing materials. What these regulations overlook is the behavior of properly installed thatch in real-world conditions. When densely packed, thatch burns slowly, as limited oxygen suppresses combustion, creating what fire researchers describe as a closed-book fire profile. Historic England, in collaboration with the Fire Protection Association over a 3-year study, determined that heat conducted through chimney walls does not ignite thatch. In reality, nearly 90% of recorded thatched fires originate from embers expelled from chimneys or from hot flue gases escaping through faulty chimney structures. Modern buildings employing heat pumps or electric radiant heating lack chimneys altogether, effectively removing the primary source of ignition. Today, fire retardant treated thatch can pass ASME 100 weight testing, a benchmark that previously excluded untreated material, though building codes have yet to reflect this advancement. Beyond fire safety, 3 additional factors maintain the rarity of thatched roofs in the United States. First, insurance presents a significant hurdle. As thatch is categorized as non-standard construction, premiums often run 3 to 4 times higher than conventional rates. Next, the scarcity of skilled labor poses a challenge. Thatching demands a minimum of a 5-year apprenticeship, yet no government-funded programs exist in the United States. The craft survives only through a small number of master thatchers trained in the United Kingdom and Ireland who have adapted traditional techniques to American materials and climates. Furthermore, the collapse of the material supply chain has contributed to the high costs and rarity of this roofing method. The large-scale introduction of combine harvesters in the mid-20th century shortened and crushed straw stems during collection, making them unsuitable for thatching. Simultaneously, modern dwarf wheat varieties enriched with nitrogen to prevent lodging under chemically enhanced grain weight produced stems too short and soft to compress into a structural roof. When these challenges converge, it becomes evident why thatched roofs quietly disappeared from mainstream American construction. For anyone considering thatch for their own structures, several critical factors must be considered. Climate plays a decisive role in determining the viability of natural thatch. In arid regions with low humidity, properly installed water reed or long straw performs, as the historical record demonstrates, providing 25 to 40 years of service and up to 60 years under ideal conditions. In contrast, humid subtropical climates, such as Florida and the Gulf Coast, reduce the lifespan of untreated natural thatch to only 3 to 5 years without intensive maintenance. In such locations, synthetic thatch emerges as the only option capable of a 50-year lifespan without retreatment. Fire protection remains another primary concern. Polyethylene or PVC systems integrate fire retardants directly into the structure, maintaining Class A ratings for their full 50-year durability. When a chimney-free design is combined with thatch bat insulation, aluminum barrier foil, and fire retardant sprays, the assembly can achieve an AA fire rating, offering 60 or more minutes of protection. For American builders, the simplest approach to utilizing natural thatch is to apply it to structures outside the International Building Code's residential classification. Outbuildings, workshops, garden structures, and off-grid cabins in rural jurisdictions often fall outside the roofing requirements that restrict thatch from primary homes. A small network of American master thatchers can provide professional services. Colin McGee, based in Virginia, has been adapting water reed techniques to American climates since 1991, specializing in Turkish water reed and fire retardant infusion for humid conditions. For those seeking to learn the craft independently, online resources such as Thatching Info offer a starting point, though mastering the trade requires substantial time and practical experience to achieve a durable, well-constructed roof. Thatch remains the oldest roofing system in human history, independently developed on every inhabited continent. Its combination of weatherproofing and thermal insulation continues to make it one of the most efficient ways to enclose an interior space. For those passionate about discovering methods and knowledge to support a self-sufficient lifestyle, exploring thatch provides both historical insight and practical benefit. Thanks for watching. See you in the next one.